Hey guys, in this video we're going to find out how to integrate sine cubed x dx. Well, first we look at this problem and we see that we have a sine x in there. And we know that the standard integral of sine x dx is just equal to negative cosine x plus c. But can we use this in this case? Well, we have sine cubed x, not sine x, so that doesn't help. And then we think about, can we use u substitution? Well, if we set u equal to sine of x, then du would be cosine x dx. Well, we don't have a cosine x in the first original problem, so this also can be used. Well, now what do we do? Well, if you recall the trig identity, sine squared x plus cosine squared x equals 1. That can be used in this case. Well, you might say we have sine cubed x, not sine squared x. Well, we can easily rewrite this as integral of sine x times sine squared x dx. All I did was I took a sine x out and then I multiplied that by sine squared x. And when you multiply these together, you get sine cubed x. Same thing. So now all I have to do is isolate this and we get sine squared x equals 1 minus cosine squared x. So if I rewrite this, sine x times, and I'm going to replace the sine squared x with 1 minus cosine squared x dx. Now I can distribute. I get integral of sine of x minus cosine squared x sine x dx equals. Now, since we're subtracting, we can split these up into separate integrals. We can say that it's sine of x dx minus integral of cosine squared x sine x dx. Now, this is a much easier integral to work with. This, as we looked at in the first steps when we were trying to figure out what method we're going to use, we know that this is a standard integral and that just equals negative cosine x. And since we have cosine x and sine x, we can use u substitution. We can say that u is equal to cosine x, then du is equal to negative sine x dx. Now I'm going to go on to the next sheet and rewrite this. So our problem was integral of sine x dx minus integral of cosine squared x sine x dx, and we set our u is equal to cosine of x and our du is equal to negative sine x dx. Well, in the original problem we have sine of x dx, so I'm just going to go ahead and divide this by negative 1. So we have negative du is equal to sine of x dx. So I'm going to rewrite this problem and substitute in the u, and while I'm at it, I'm just going to go ahead, and since this is just a standard integral, I'm going to just write the answer for that. So that's negative cosine of x minus integral of negative u squared, because cosine is squared, du. And the negative just comes from the du that I divided by negative 1. And now I can take the negative out, and that just becomes negative cosine x plus integral of u squared du. And now this is just how we would integrate anything else. Just add a 1 to the exponent and divide by that new exponent. So we have negative cosine of x plus u cubed divided by 3. And since the original problem was an indefinite integral, don't forget the plus c. Now just substitute in the u with cosine x, and this just becomes negative cosine x plus cosine cubed x divided by 3 plus c. And I know I wrote out every single step. Maybe you don't need to do that, but when you're practicing, it's good to talk yourself through the steps and figure out what you're going to use, because that really helps you figure out what method you're going to use and why a specific one doesn't work in a specific situation. So I always think it's better to talk yourself through the practice problems. And that's it. I hope this video was helpful. If you have any questions, don't hesitate to comment below. If you haven't already, subscribe, and I'll see you guys next time.